Good morning, I'm Eric Henriksen. They're one of the most destructive forces on the planet, earthquakes. And I visited a special lab at UT where they make miniature versions of these and took a closer look at how healing can cause more damage. At UT Austin's Geomechanics and Geofluids lab, scientists are getting a better understanding of earthquakes.
With a test like this, I will check in once a day, take an acoustic measurement, and then make sure everything's looking okay.
PhD student Peter Miller learns how water moves through rock.
You take a sediment and you just squish it like a sponge and water's going to come out.
While PhD student Caitlin Scheibel creates a miniature fault line.
You're going to drive this forward and it's going to slide along, and so that's simulating like the two rocks sliding against one another.
It's not just the Earth's movement they're recreating. This device, for instance, can simulate pressure felt several miles beneath the Earth.
It's like being under the earth where everything's being squeezed.
Different rocks react differently under pressure.
These were collected off the coast of New Zealand on a drilling expedition in 2018.
These New Zealand samples helped the team discover something fascinating.
They're like heels, and so then when you slide again, it actually takes like more force for you to get it to continue to slide.
So you can actually see up close, there's sort of some streaking on this.
Damian Safer, director of the UT Institute for Geophysics, says fault zones with a lot of clay are slow to heal.
If that healing is very small, then it doesn't take very long before you can build up enough stress to break the rock again, to overcome that healing.
Which means the earthquakes have less power and are less destructive. These slow earthquakes are common in New Zealand.
Japan is another area that has these sort of strange slow earthquakes.
Unlike a traditional earthquake, slow earthquakes occur over several days or even weeks, releasing the energy of the Earth so slowly you may not even notice it.
It's this big discovery 20 years ago, and it kind of changed the way we think about how earthquakes work.
Rock heals at different rates, which the experiments of the lab can help determine.
We're sampling the different rock types that might be involved in the faulting.
Safer says by understanding the rock, they can answer,
where are the areas that are most likely to have a big earthquake? Where is the hazard high? Where is it low? Where is the propensity for big earthquakes to happen?
Big questions to an Earth-sized problem. In Austin, Eric Henriksen, KXAN News. What's next for earthquake research? Large-scale experiments that can simulate the Earth's heat and long-term experiments that last not just days, but months or even years.